Alright students, so today we are looking at applying properties of logarithms. Particularly we're going to be utilizing the formulas, the product property, the quotient property, and the power property of logarithms, which we saw in a previous video. So, according to this, it says fill in the missing values to make the equations true. We have log base 8 of 11 plus log base 8 of 7 equals log base 8 of something we don't know what that is. So alright, here we have a log of a plus log of b, so that's going to be 11 plus 7, so log base 8 of 18. That's 18 goes inside that box there. Alright, look at this next problem. Oh, I already got the answer right there for us. So we have on the right hand side log base 3 of 8 divided by 7. That's going to be log of 8 minus the log of 7. I'm not even going to say the base here. They make sure that all the bases line up. So this problem right here, 2 times the log of 5, so that'd be the log of 5 squared. So 25 is what they're looking for in that box. Great. Here we have another log a minus log b situation, so that's going to be log a minus b. So, or sorry, a minus log of a minus log of b is log of a divided by b rather. So that would just be 3 over 4. Here we have log a plus log b equals log of, this would be a times b. So 9 times something equals 99. Wonder what it is. 11. Here it's a little bit different. We have log base 7 of 16 equals something times log base 7 of 2. So we got to kind of think of, alright, so it's looking for a number right here which would correspond to an exponent here. So 2 to the what power would equal 16. So just another way of writing that, we're saying 2 to the 4th. So this would be a 4. So 2. Alright, let's scroll down and find another question here. So alright, here this says use the properties of logarithms to evaluate each of the following expressions. So we have log base 12 of 3 plus 2 log base 12 of 2. Now could you type this in a calculator? Yes, but I don't need a calculator. You don't need a calculator. Let's just use property of logs. So that 2 multiplier right out there is going to come into play. So this is going to be log base 12 of, so if I think that 2 could be brought up here, so 2 squared, so, and now I have, so 4 over here on the right hand side, or on the right side of the left hand side. Anyway, log of 3 plus the log of 4 is equal to the log of 3 times 4, so log of 12. Now it's log base 12 of 12. You remember one of those properties of logarithms that if you have the base and this number right here the same, then that's equal to 1, because 12 to the first equals 12. So that's great. It's not always going to be 1 though, because if we look here we have natural log of e to the 11th minus natural log of e to the 7th. So this is going to be natural log of e to the 11th divided by e to the 7th. So if we apply our property of exponents here, same base, so that would be natural log of e to the 4th. Now we can apply our property of logarithms, pull that 4 down, so 4 times the natural log of e. And we saw earlier that natural log of e is equal to 1, so 4 times 1, and then this gives us 4. There are other ways of doing that problem, but this is a good way that uses those properties of logarithms. Another type of problem that we're looking at is how to expand a logarithmic expression. Here, so we have log of x over y squared. We want to make sure that our final statement doesn't only has one variable for each logarithm and does not have any exponents. So, and we are assuming the variable is positive. So this is going to be log of x minus log of y squared. So you can see because we have the log of a quotient is equal to the difference of the logs. So, but then that 2 we can bring out front. So log of x minus 2 log of y. Alright. We'll do the same kind of thing here. We can split up this expression right here. So we'll write that as 4 log z minus log of x. And this gets to be pretty quick. for us. All right. The only way we can make this a little more difficult is by having a more difficult and complicated expression there inside the logarithm. So I'm going to first rewrite that cube root as y squared times z to the 1/3 power. Then I'm going to split this up, so I'll say that's log of x to the 7th minus log of the whole denominator, because notice we have a division. So the quotient, the log of a quotient is equal to the difference of those logs, difference of the numerator and denominator. So log y squared times z all to the 1/3. Now that 1/3 I can pull out here. So we have log x to the 7th minus 1/3. And then this log of a product, I'm going to write that as log of y squared plus log of z. That exponent there is the 2 I can bring out as a coefficient. At the same time, I'm also going to distribute that negative 1/3, and I'll bring that 7 out here to the front. So I now have 7 log x minus the 1/3 times the 2 is minus 2/3 log y, and the negative 1/3 just distributed over here is negative 1/3 log z. That's a great answer. That is a simplified, or actually I don't know if it's an expanded logarithmic expression. I'm not going to do this one all the way, but I will set it up here so you can kind of see that cube root. Once again, we're going to write that as all that stuff, x to the 7th z over y squared, and then put as 1/3 power out there, which then I can pull out as a coefficient, and then I could say that's 1/3 times log x to the 7th plus log z minus log y squared. We could pull those out, they distribute, and end up with a happy answer. I'll leave that kind of activity to you. This is the only other type of problem I think that you could possibly have along these lines, and that is where you have an expanded form of a logarithmic expression and you're wanting to condense it into a single logarithm. So notice I have 7 log of w, so I'm going to bring that 7 now to the exponent, so log w to the 7th minus at 1/5 I'm going to bring as an exponent up here, so log x 1/5, and that's 6 also right there. Now remember, you can rearrange addition and subtraction, so I'm going to just grab this first term in the second, or in the third term here, and so I'll say log base 7 of w to the 7th times z to the 6th, and then divided by, since we could kind of throw that subtraction at the end, x to the 1/5. All right, that's it. Those are applying the properties of logarithms. Good luck doing this on your own.